databases. And our main source is this article, NoSQL nedir ve ne zaman kullanılır. It's from Data 101. Seems like a lot of you are really looking for like a crash course on NoSQL,
Right.
you know, like what they are, when to use them, and maybe, just maybe, a few aha moments along the way.
You bet. NoSQL databases are, well, they're becoming increasingly vital,
Yes.
especially when we're dealing with these massive data sets or, applications that just have to be lightning fast. And there's not just one type of NoSQL database out there, right? It's a whole family.
Okay, so first things first. What is a NoSQL database? I mean, the name kind of gives us a hint, but what makes it different from those, those traditional databases that we're all kind of used to?
Yeah, the name it's definitely a good place to start. NoSQL, it stands for not only SQL, right? And that means, well, there's a whole world of databases, like beyond the traditional ones, the relational kind. Like think of those structured databases with all the rows and columns, like a really organized spreadsheet. NoSQL is, well, it's about breaking free from that structure.
Makes sense. And our source, it highlights some key characteristics, right? Like flexible schemas, horizontal scalability, high performance, and distributed architecture. But why are those so important? Like, what's the big deal about, say, flexibility? Why is that such a game changer?
Well, imagine you've got data that's constantly changing, like user profiles on a social media site or product information for like an e-commerce platform, a rigid database structure. That'd be a nightmare to keep updated. But NoSQL databases, they can adapt. They can change without breaking a sweat. And that's the beauty of flexible schemas.
So it's like having a database that can evolve. I like that. And what about horizontal scalability? Why is that so important? Especially when we're talking about, big data and all that.
Think of it like this. As your data grows,
right,
you just add more servers to your NoSQL database. And that way it can handle the increased load. It's like expanding your storage capacity. But without having to like rebuild the whole system from scratch. And that's essential for companies like Netflix. Think about how much viewing data they have. It's mind-boggling.
That's a really good analogy. I get it. And then there's the need for speed, high performance. Why is that so essential in some applications?
Speed is everything when you're dealing with real-time data or applications where even like a millisecond of delay, that can make a difference. Imagine a stock trading platform or a real-time bidding system. You need a database that can keep up with all the transactions, and it has to deliver results instantly. That's where the high performance of NoSQL databases, well, that's where it comes in.
Okay, so NoSQL databases seem like they have a lot to offer, right? Especially in today's world where data is everything. But let's be realistic. Are there any times when a traditional SQL database, would it be a better choice?
For sure. If you're working with data that has a very predictable structure and complex relationships between different pieces of information, well, a relational SQL database, it might still be the best fit. Think about things like financial transactions or scientific data, where accuracy and consistency, they're really important, paramount even.
So it's not about like one being better than the other. It's about choosing the right tool, right? The right tool for the job, right? It depends on the specific needs of the project.
You got it. And that brings us to the exciting part, right? Exploring all the different types of NoSQL databases, because it's not just one thing, It's a whole spectrum of options. Each one has its strengths and its ideal use cases.
Okay, I'm ready to dive into the NoSQL family tree. What are some of the main like branches? I've heard of key value stores. Is that just it, or is there more to it than that?
Oh, there's more. There's definitely more. But let's start with key value stores, because they're the simplest and often the fastest. Think of them like a giant dictionary. You've got a key, right? And it's got an associated value. It's really efficient for storing and retrieving, simple pieces of data.
Like storing, I don't know, user session data or quickly looking up like product info based on a product ID. I can see how that would be really useful. What are some real world examples of key value stores like in action,
Well, think about Netflix.
Yeah.
Like, how do they remember what you've watched? Right. Or Twitter, how do they track trending topics? Those are key value stores working hard behind the scenes. They've got to handle a ton of data, but the data itself is, well, it's relatively simple, right? So it's a perfect fit for key value stores.
So it's all about speed and simplicity.
Yeah.
Got it. But But what if we need to store more complex information? What other types of NoSQL databases are out there? Like what can handle that kind of challenge?
That's where document databases come in. They let you store data in a more flexible format, like JSON documents, kind of like storing information in folders, right? Organized folders.
Yeah.
And each folder, well, it can hold different types of data.
So instead of forcing everything into rows and columns, we can store it in a more natural way, like a hierarchy. That sounds pretty powerful.
It is powerful. And companies like eBay and Facebook, they've embraced document databases for that very reason. Think about all the data eBay has. Product descriptions, images, user reviews. It's a lot. A traditional database would struggle.
Yeah.
But document databases, they handle it with ease.
That makes sense. And Facebook, they use it for everything. User profiles, posts, interactions, it's all in there. I'm starting to see how document databases are, they're a game changer for platforms that have to handle, a lot of different types of data that's constantly changing too. But what about when we need to process truly massive amounts of data, like for analytics,
Yep.
Is there no SQL solution for that?
Oh, absolutely. For that, you want to use column family stores. They're designed for storing and querying massive data sets. And they're really good at handling data that's structured in columns rather than rows.
So instead of rows of data, we're focused on the columns. How does that make a difference?
Okay, imagine a huge spreadsheet, right? Millions of rows, but you only need to analyze a handful of columns. Column family stores, they let you access and process just that data.
Yeah.
Just the data you need without getting bogged down by all the rest. They're perfect for applications like Instagram, where they need to analyze all that user activity and all the interactions, and they have a lot.
Wow, so they're like the heroes of big data analytics, working behind the scenes. It makes sense that companies like Google, with all their data, they'd be using this type of database. Are there any other types of NoSQL databases we should know about?
There is one more, and it's a really interesting one. Graph databases. They're all about relationships, connections between different data points. Think of social networks or recommendation engines or any application where understanding the links between things, it's really important.
Intriguing. Can you give me an example, like a real world example of how graph databases are used?
Sure. Think about Uber, like how they connect riders and drivers. They need to understand those relationships between users, you know, and their locations and the time to make sure those rides happen and they happen efficiently. A graph database it's a perfect fit for that because it lets them model those complex connections and then analyze them, in real time.
So it's like having a visual map of all the connections in your data. That's fascinating. And companies like Facebook, they've obviously got to be using this type of database, right? With their massive social network.
Exactly. And it's not just social networks. Companies like Airbus, they're using graph databases to model entire airline networks. It's all about understanding those connections.
Yeah.
Right? Between different entities.
Yeah.
And how they interact.
Okay. So we've got key value stores for speed and simplicity, document databases, those are for flexibility, column family stores, those are for processing massive amounts of data. And then we've got graph databases for understanding all those relationships. It's like a whole NoSQL toolkit, right? to tackle any data challenge.
You got it. And now that you've got, a good grasp of all the different types, well, we can dive into the key principles of, designing systems that really use their strengths.
Sounds good. I'm ready to explore, the art of NoSQL design.
So ready to jump into NoSQL design. Now that we've explored the landscape a bit, met all the major players, it's time to focus on actually designing systems that really harness the power of NoSQL.
I'm definitely ready. I gotta admit though, thinking about designing for NoSQL, it's a little intimidating. Like where do we even start?
Yeah, that's a fair feeling. It's different, right? Designing for NoSQL, it often requires a different mindset compared to traditional databases,
Yeah.
The relational kind. But don't worry, our source gives us some guiding principles. One of the most important ones is understanding your access patterns.
Access patterns. What does that even mean? Like in the context of NoSQL,
Okay, it's about anticipating how your data is going to be used.
Yeah.
Like what are the most common queries? or
Yes.
operations that your system's gonna perform. And then your database design, well, it should be optimized for those, for those specific access patterns.
So if I'm building like, I don't know, an e-commerce site, I should make sure that, product details and recommendations, those are easily accessible because those are things that users are going to be, doing all the time.
Exactly. That's the example our source uses.
Mhm.
In a document database like MongoDB, you might choose to embed, the product details
Right.
and the recommendations all in the same document.
Yeah.
So it minimizes the time it takes to, to retrieve all that information.
So it's all about, structuring the data in a way that makes sense, that aligns with how it's going to be used,
Yeah.
right? Okay. That makes sense. What other principles should we keep in mind?
Horizontal scalability is, well, it's another crucial one. Remember, we talked about NoSQL databases being designed to scale out, adding more servers as your data grows.
Mhm.
Well, your design, it should embrace that from the get-go.
So it's like planning for the future, making sure our system can handle, all that growth and the increasing load.
Exactly. Think about Twitter, right? They use Redis. It's a key value store. They use it to manage all the user session information.
Yeah.
And they've designed their system to scale horizontally, seamlessly as their user base keeps growing. It's about anticipating those demands.
Yeah.
And building a system that can adapt.
That foresight, that's key. What else is on our NoSQL design checklist?
Flexible schemas are, well, they're essential. We talked about how NoSQL databases can handle, data that's evolving. Well, flexible schemas, they're the key to that adaptability. You don't need to define the structure of your data up front,
Yeah.
rigidly. It can evolve as your requirements change.
So it's like having a database that can, grow along with your application, adapt and grow.
Yeah, that's the idea. Our source gives a really good example, e-commerce platforms like Amazon.
Mhm.
Each product, it can have a unique set of attributes. And those attributes, they might change
Yeah.
frequently. Using document databases with the JSON format, it allows them to accommodate all that data, all that diverse changing data.
It's a far cry from those rigid tables we see in traditional databases. Okay, so I'm starting to see how all these principles, they kind of work together. But what about this next concept? Denormalization. It seems kind of backwards, from everything I've learned about database design.
Yeah, denormalization, well, we call it strategic denormalization. It is a bit of a departure, from the traditional thing. In relational databases, we really try to normalize everything, eliminate redundancy to make sure the data's, it's all good, has integrity.
Right, minimize all the duplicated information as much as possible. But
Yeah.
with NoSQL, we sometimes do the opposite. We intentionally duplicate things. Why would we do that?
Well, it's a trade-off,
Yeah.
between storage efficiency and query performance.
Yeah.
Sometimes it's better to repeat certain pieces of data so
Yeah.
you can speed up retrieval.
So it's like having, I don't know, multiple copies of a map, so you can find your way quickly without having to constantly go back to the original.
Yeah.
Makes sense in a fast-paced environment, where speed is everything.
That's it. The source mentions news platforms
Mhm.
as a good example.
Mhm.
They might store, the article headlines and summaries and the author information in multiple collections. So all that stuff loads quickly for users.
That's pretty clever. But now we're getting into some really, really heady stuff. The CAP theorem. I've heard of it, but I got to be honest, it's always seemed a little scary.
Yeah, the CAP theorem is, well, it's a fundamental concept in distributed systems. And it has some pretty big implications for NoSQL design. It basically says, in a distributed system, you can only guarantee 2 out of 3, desirable properties: consistency, availability, and partition tolerance.
Okay, let's break that down a bit. What do we even mean by consistency in this context,
Consistency means that, well, that every read operation, it's going to return the latest write. So no matter which server you're talking to, you're going to get the most up-to-date information.
So it's like making sure that everyone has the same version of a document, even if multiple people are editing it from different locations.
Yeah, good analogy. Now, availability,
Mhm.
well, that means the system is going to stay responsive.
Yeah.
Even if some parts of it fail. So if one server goes down, others can pick up the slack, keep everything running.
That sounds pretty crucial for applications where downtime is just not acceptable, like e-commerce sites or online banking. And what about partition tolerance?
Okay, partition tolerance, that means that the system, it can keep working, keep operating, even if there's a network partition. You know, that's a situation where different parts of the system, well, they can't talk to each other.
So it's like having a backup plan in case the communication lines, they go down. But if we can only choose 2 out of those 3, how do we decide which ones to prioritize?
That's the hard part. And the decision, well, it depends on the specific needs of your application. Our source, it gives some helpful real-world examples, like financial systems. They prioritize consistency and availability above everything else. So you need to make sure those transactions are always accurate and that the system is always up and running.
Right. You can't have, money disappearing or accounts becoming like inaccessible because of inconsistencies or downtime. But other applications might have different priorities, right?
Exactly. E-commerce platforms, they might lean towards availability and partition tolerance.
Yeah.
For things like product recommendations.
Yeah.
They'd rather have the system stay up and running, even if the recommendations aren't, perfectly consistent all the time.
So a slightly outdated recommendation, that's a minor inconvenience compared to the site crashing, being unavailable, right? It's about choosing the trade-off that makes sense for the users.
That's it. And then you've got social media platforms like Twitter. They prioritize availability and partition tolerance for real-time updates. They want to make sure those tweets are delivered quickly, even if there are some occasional network hiccups.
Yep. So in that case, speed and responsiveness, those are more important than having perfect consistency every second, The CAP theorem, it's tough. It makes us make some tough choices. But understanding those trade-offs, that's essential for designing systems that are robust and resilient,
Couldn't agree more. The CAP theorem, it highlights that there's no one-size-fits-all solution. It's about, making informed decisions.
Yeah.
Design decisions based on the needs of your application. Now, beyond the CAP theorem, there are a few other design considerations.
Yeah.
That are specific to NoSQL that we should explore.
Okay, I'm ready for the next level. What else should we be thinking about?
Balancing read and write loads. That's really important, especially when you're dealing with high volumes.
Yeah.
Of both types of operations. You want to distribute your data in a way that avoids bottlenecks and make sure the performance, smooth.
It's like managing traffic, right? But for data instead of cars.
Good analogy. Our source, it points to online gaming companies like Wyatt Games. They use NoSQL databases.
Yeah.
Like React to handle all that traffic, all those reads and writes that are generated by, player actions, leaderboards, all that stuff.
Those leaderboards are constantly being updated, right? As players compete. So I can imagine the database really has to keep up with all that, all that information.
Exactly. And that brings us to another important concept, sharding.
Sharding. I've heard the term,
right.
But can you remind me how it works and why it's so important for NoSQL?
So sharding is about breaking up your data.
Yeah.
Into smaller pieces, more manageable pieces. We call them shards, and then you distribute those shards across multiple servers. It's like dividing up a giant library into separate sections, so it's easier to find books.
Yeah.
And manage the whole collection.
So it's about breaking down complexity, making the data more and more manageable for both storage and retrieval. How does sharding actually work? Like in practice,
Okay, consider Instagram. They use sharding to handle all their user data and all their content data. They might shard their data based on region and user IDs, so that way users in a specific area, well, they can access their data quickly from nearby servers.
So it's like having like regional libraries that cater to local communities. That makes a lot of sense. What other design considerations are there?
Choosing the right consistency model. That's essential. Remember, consistency refers to how strictly the data needs to be synchronized, across the database. There are different levels of consistency. And the best choice, well, it depends on your application, what it needs.
So it's like deciding how often everyone needs to synchronize their watches to make sure they're all on the same page, right? Some applications might need perfect synchronization all the time, while others can tolerate a little bit of, a little bit of lag.
Exactly. Our source, it highlights Amazon's approach.
Yeah.
Which is pretty clever. They use different consistency models for different functions.
Yeah.
Inventory management, that demands strong consistency to make sure the stock levels are accurate. Well, product recommendations, those can tolerate eventual consistency, meaning the data, well, it might not be perfectly synced all the time.
That's a smart approach, tailoring the consistency level to what each function needs. It seems like flexibility is a big theme in NoSQL design. Are there any other key principles we should cover?
Of course. One that's, well, it's often overlooked, but it's incredibly important. Backup and disaster recovery. No matter how well you design your system, things happen. Unexpected things.
Yeah.
You need to plan for the worst case scenario. Make sure your data is safe and can be recovered if something goes wrong.
Right. Backups are like insurance. Right. For your data, they might not be exciting, but they're essential.
Exactly. Our source mentions PayPal. They use Cassandra's backup and data replication features to make sure that their system is always available and that their data is, it's protected.
So we've covered a lot of ground. Designing for NoSQL, it definitely requires a different way of thinking, but it's all about embracing flexibility, scalability, and thinking outside the box, right? Outside the traditional relational box.
Yeah, and remember, these design principles, they're guidelines, right? Not hard and fast rules. The best approach, well, it always depends on your project, what it needs.
That's a good point. It's all about understanding the tools and the principles and then applying them creatively to solve those real world problems. And speaking of real world problems, I mean, I'm curious to hear your thoughts on, how NoSQL databases are being used to tackle some of those really big data problems that we're facing today.
That's a great segue. NoSQL databases are, well, they're at the forefront of a lot of exciting developments. In fact, let's shift gears a bit, and dive into some real world case studies.
Yeah.
Showcase the power of NoSQL in action.
I'm ready. Let's do it. Wow, that NoSQL design deep dive, that was pretty intense. I am starting to see how these databases are, well, they're kind of shaking things up, right? Like changing how we think about data.
It's a real paradigm shift, yeah. And I think what's really exciting is how they're being used to solve problems that we just couldn't solve before. It's like a whole new set of tools for all the data challenges we're facing today.
Right. So let's take a step back for a second. Look at the bigger picture. Why are NoSQL databases becoming so important? Like, what makes them stand out?
Well, first of all, NoSQL databases, they're great at handling, well, just the sheer volume of data.
Yeah.
We're talking about massive data sets here, like terabytes. Even petabytes. Traditional databases, they would really struggle to keep up with that.
Right. It's like trying to fit, I don't know, an elephant in a shoebox or something. Yeah. NoSQL databases they're designed to scale out, right? Horizontally, so you can just add more servers as the data grows.
Exactly. And it's not just about the volume. NoSQL databases are also designed for speed. They can handle all that data ingestion and process it quickly. So they're great for applications that need insights in real time.
Like social media feeds, right? Those are constantly updating new posts, comments, likes, all that. Or financial trading platforms where they have to process transactions in like milliseconds. Speed is everything there.
It is. And then there's the flexibility. NoSQL databases, they can handle unstructured data, semi-structured data. So they're perfect for applications where the data model is, well, it's always evolving,
Like e-commerce platforms, where there are always new product categories, new attributes, or social media platforms where the interactions and the content, it's always changing, right? NoSQL databases can just adapt to those changes without needing a complete system overhaul.
Yeah, that adaptability it's really key. So to recap, NoSQL databases, they offer a really powerful combination, scalability, speed, flexibility. It makes them ideal for all the data challenges we're facing today.
And by understanding the different types, and their strengths and the design principles that we've talked about, well, I think our listeners can really start to see how NoSQL can be applied to their own problems in their own fields.
Yeah, absolutely. It's about empowering people, giving them the knowledge to choose the right tool. and then to design systems that really leverage the power of NoSQL.
And I think it's important to remember that NoSQL, it's not just about, the tech. It's a new way of thinking about data.
It is. It's a shift, right, from that rigid schema-driven approach to something more flexible, more adaptable. It's about embracing the fact that data changes. It's fluid. It's always evolving.
And recognizing that there's no one right answer, no one size fits all solution. The best approach is going to depend on the application and the data itself, right? What are its characteristics?
I couldn't agree more. It's about choosing the right tool for the job, and then applying those principles, those design principles, to create a system that meets those needs.
Okay, so to wrap things up, I wanna leave our listeners with a question to think about. What if we stopped thinking about SQL and NoSQL as rivals? What if we saw them as complementary?
That's a great point. It's about moving beyond that versus mentality, and realizing that different databases can they can coexist. They can even work together to create really powerful solutions.
Exactly. Sometimes it might even make sense to use a hybrid approach, use the strengths of both SQL and NoSQL to create a system that's really robust and adaptable. So as you continue on your data journey, keep exploring, keep experimenting, and don't be afraid to think differently, challenge those conventional ideas.
And remember, if you want to dive deeper into a specific part of NoSQL, or explore a specific use case, well, you know where to find us. Just request another deep dive.
Until next time, everyone, happy data wrangling.